or else this is the last problem that I have for you today. Okay. So the typo that I mentioned in the previous video is this part. So I wrote 18 in our homework paper, but it's 1/8. Okay. All right. Now I'll have you pause the video and then I'll have you come back. Okay. All right. Now I assumed that you try to solve this problem once more. And okay, I'm just gonna go ahead and explain. Okay, first it says it's rainy 1/3 of the days. Then what that means is the probability that it rains is 1/3. Then we can definitely see that the probability that it doesn't rain is 2/3. You know what I mean? And now, given that it is rainy, there is a conditional probability thing going on here, and there will be heavy traffic with probably 1/2. Then there's a probability that when it's raining outside, uh, there will be heavy traffic, which is just 1/2. Now, there's no heavy traffic outside when it's rainy, then it's going to be 1/2. You need to understand that why this is 1/2. Uh, do you remember what I talked about when I first explained the conditional probability thing here? So, like what I mentioned before, is, uh, so when you define just a normal probability, then is defined as number of A over number of elements in the number of the elements in the sample space, right? What is the probability? What is this then? Probability of B. No, not that. Probability of A given B is we have PB in the denominator and then PA intersection B in the numerator. So what I'm trying to say here is that now our sample space has been reduced to PB. You know what I mean? So what I mean right now is that the sum of 1/3 and 2/3 is just simply 1. And now what you need to understand is that sum of 1/2 and the sum of 1/2 is 1. And you know that, right? But here, it should not. The sum of these two should not create 1/3. A lot of people think that, hey, teacher, why is this 1/2 and 1/2 and it creates 1/3? Because of this. Because of this. Now, our sample space, in this case, the probability that it rains, so if I rewrite that, the probability that it rains is we are comparing the ratio to the sample space, but now we are talking about HR, then now PR is our sample space, our new sample space. Our sample space has been reduced to PR. So we have this event conditioned on R. Okay, so that's why the sum of these two should be just 1. All right. Then probably of R, probably that it rains, and probably that there will be heavy traffic given that it's raining outside. It's just 1/2, right? As it is given in the problem. So okay, now given that it's not raining, there will be heavy traffic with probability 1/4. Then here over here, the probability that there will be heavy traffic when it's not rainy is 1/4. Then we can definitely see that the other hand here is 3/4, right? Then if it is rainy, there will and then the next sentence here is that if it is rainy and there is heavy traffic, I arrive late for work with probably 1/2. Then rainy, heavy traffic, late for work. Let's just put that as W, and then it is 1/2, right? And then there is no heavy traffic. The probability that he's not late for work is 1/2. And it says, on the other hand, the probability of being late is reduced to 1/8. If it's not rainy, there is no heavy traffic. So it's not rainy, there is no heavy traffic, that the probability is going to be reduced to 1/8. The probability of him being late is 1/8. So it's 1/8 over here. And then this is 7/8 then. And it also says, in other situations, the probability of being late is 1/4. What that means is, here, rainy, no traffic. Then R and is intersection, no traffic, therefore H complement, we are talking about this one here. Therefore, in this case, the probability of being late, which is W, this is 1 over 4. The probability of him not being late is 3 over 4. Okay? Now, here we are talking, this first was talking about this one, and the second here, uh, not rainy, which is R complement, and is intersection, traffic, H, is over here. And the probability of him being late is again 1 over 4. Therefore, W is 1 over 4, and then W complement is 3 over 4 down here. You understand? So now we completed this tree diagram thing. So now let's solve the problem. Okay. 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 A, it says, what is the probability that is not raining and there is no heavy traffic? There is heavy traffic, I'm not late. Okay, let's rewrite that. The probability that it is not raining, which is R complement, and there is heavy traffic, H, and I'm not late, therefore W complement. We're looking for this. Then, okay, I can solve this mathematically, and I can solve this just with looking at this tree diagram. I'll do both. First of all, then, just looking at this, we need to just look for this 2 over 3, right? 2 over 3 times H 1 over 4, and then times not late for work, therefore 3 over 4. Therefore, if you just first calculate the answer here, then it is just 1 over 8. Okay? Then if we are just doing it looking at the tree diagram, but if you're not looking at the tree diagram and still need to do it, then what we need to do is this. First, P, the probability that it rains outside times the probability that it is not there will be heavy traffic when it rains, and then times the probability that there will be heavy traffic outside. I do not have space, so I will just erase that and then write it down over here. The probability that he is going to be late for not late for work, and then there is given that it's not raining outside and there is no heavy traffic. So it can be calculated this way. But I mean, doing this and doing what I just did, they're exactly the same. Okay? As you see, it looks a lot like the chain rule. The chain rule, right? They cancel each other out, and then over here, uh, H and RC over here, they cancel each other over here, and then what we're left here is kind of like this. So let me just rewrite that over here. Hold on. Okay, let me if I rewrite that, then what ends up being is P R complement times P H intersection R complement over P R complement times P R complement intersection H complement WC over P H intersection R complement. So what is left is just this part. Okay, so it is a chain rule in the conditional probability. Okay, so all right, I think I need to come back in the next video.